Balancing chemical equations. In part 1 of this series, we reviewed the vocabulary used in balancing equations. In part 2, we practiced counting atoms. And in this third part, we will learn how to do the actual balancing. Many people can easily balance equations in their head by simply going through a mental count of the atoms on the two sides of the equation. This approach is the final goal for any student, but if it cannot be achieved immediately, there is no harm. In fact, there are many benefits to doing the work the long way. The long way follows an algorithm that is basically a systematic version of all the steps that the mind performs in balancing an equation. This is what balancing equations is all about. You are given an equation of a chemical reaction, and you must decide if it is balanced. If it is, all is fine and good. But if it isn't, then you need to balance it. For example, H2 plus O2 yields H2O. Start by counting atoms in order to compare reactants and products. Remember, when you don't see a subscript or a coefficient, it means you have one of that element or compound. In this reaction, there are 2 atoms of hydrogen on the reactant side and 2 atoms of hydrogen on the product side. The hydrogen atoms are balanced. There are 2 atoms of oxygen on the reactant side, but only 1 atom of oxygen on the product side. The oxygen is not balanced. Therefore, the equation is not balanced. This is like having an incorrect recipe. And with chemical formulas and chemical reactions, there is only one correct recipe. Your job is to recognize an incorrect recipe and to correct it by giving the right amount of each substance. In other words, you need to balance the equation. To become proficient at balancing chemical equations, it is important to recognize the type of equation in order to decide on a strategy. We will start off with simple, straightforward equations and progress to the more complicated types. And we will do this by first going through the algorithm, then practicing the technique on paper, and finally doing it in our head. Let's start with the equation. Ca plus O2 yields CaO. A count of the elements indicates that the equation is not balanced. And so we start balancing. Begin by copying the equation. Under the equation, draw a T to separate the reactants from the products. List all the elements on the reactant side, then all the elements on the product side. Count elements on both sides. Check the numbers and start with the unbalanced element. In this case, only O is unbalanced. Go to the side with the smaller number. In this case, it is the O on the product side. Write a multiplication sign, then a circle, then an equal sign, then the number 2 to make it match the reactant side. This is to indicate that you will multiply 1 by a certain number to make it equal to the number on the reactant side. Place the number 2 in the circle. It is the new coefficient for the compound that contains O. Place that number in front of the CaO in the equation. Remember the rules. You cannot split a compound by placing the coefficient 2 in between the Ca and the O. and you cannot change the formula by placing a subscript of 2 after the O. Do a recount on the product side, the side you are working on. Note that by placing the coefficient of 2 in front of the CAO, you have effected a change in the number of CA. You had 1 CA, but now you have 2. Cross out the number 1 and write the number 2. Restart the process of comparing numbers and repeat the steps until every element is balanced. Check numbers and start with the unbalanced element. Now, CA is unbalanced. Go to the side with the smaller number. In this case, it is the CA on the reactant side. Write a multiplication sign, then a circle, then an equal sign, then the number 2. This is to indicate that you will multiply 1 by a certain number to make it equal to the number on the product side. In the circle, write the number 2. The number in the circle is your new coefficient for CA on the reactant side. Place that number in front of the CA in the equation. Note that by placing the coefficient of 2 in front of the CA, you have not affected a change in any other elements. Do your final check. 2 CAs on the reactant side match 2 CAs on the product side. 2 O's on the reactant side match 2 O's on the product side. The equation is balanced.
Yay!
Now let's try another example and see how it's done on paper. We start by writing out the equation. H2 plus O2 yields H2O. You make a T underneath the equation and separate the reactants from the products. You go back to the reactant side and list all the elements. I have H, I have O. Go to the product side and list the elements. I have H and I have O. Then go to the reactant side and count. There are 2 H's and 2 O's. Go to the product side and count 2 H's and 1 O. The H's match, but the O's don't. You go to the side with the smaller number. You write a multiplication sign, a circle, equal to, and then write the number that matches the other side, 2. In the circle, you put the number that when multiplied by 1 will give you 2. This is the number that becomes your coefficient. The number 2 goes in here. Remember, I cannot write H2O2 because this will change the product and it makes it peroxide. It was water before, now it's peroxide. And to write it as H2, 2O is totally wrong. We put the coefficient in the front of the product. We go back and count. There are 2 times 2 H's now. So whereas before we had 2 H's, now we have 4. We do another check. I have 4 H's here and I have 2 H's here. I go to the side with a smaller number. Write a multiplication sign, a circle, equal to, and I use that 4 to match it. The number in the circle is going to be 2. And this is why it's important to put the number in circle so you do not get confused between the 2 here and the 4 there. This 2 is your new coefficient. It goes in front of the H2. Now I have 4 H's and 4 H's. I have 2 O's and 2 O's. The equation is balanced. Let's see how it's done in our head. Start by counting the atoms. I have 2 H's here and 2 H's there. I have 2 O's here, 1 O there. Put a 2 there. Now I have 4 H's. Make the other side 4 H's by putting a 2 there. Now let's do a final count, 4 H's, 2 O's, 4 H's, and 2 O's. The equation is balanced. The two equations we practiced were simple and straightforward, and it is only after we start looking at other types of equations that we begin to recognize their simplicity. But simple though they may be, it is important to practice. Here are some examples for you to work on. On the side, I have included the coefficients so you can check your answers. Meanwhile, here's what's in store for you. In the next video, we will look at more complicated equations, but we will continue using this algorithmic technique and tweak it for the different types. Thank you for watching, and I hope this video was helpful.